Hi everyone, my name is Jeremy Strutch. I'm a senior network engineer at Network to Code, and today I'll be talking about giving an introduction on sources of truth and specifically NetBox as an SOT for your network potentially. Let's go ahead and dive on into it. First off, if you haven't heard the term source of truth before, I'm going to go through in depth, explain what that is, kind of what the concept behind the term, and then in the later part of the presentation, we'll talk about how NetBox can be a source of truth for your network. So first off, what does the phrase source of truth actually mean? Even if you're fairly new to it, you've probably heard it in passing before, maybe have some idea of the context behind it, but maybe not a full appreciation of really what it entails. Personally, I'm not really a big fan of the term, to be honest. It's a little vague, I think, but I haven't come up with anything better, so we'll stick with that. To better understand the concept, an analogy might be of value here. So let's say I want to build a house. What do? Well, there's a process for this, right? First, we're going to gather requirements. How many bedrooms does the house need? How many people are going to be living there, right? How many bathrooms? How many cars go in the garage? So forth and so on. Once I've gathered those requirements, I'm going to start with the design. So to do that, where do rooms go? How many floors are there going to be? Do I put the bedrooms upstairs or downstairs? Where do bathrooms fit in? How can I create hallways to connect them? What color are we going to paint the house when we're done? Stuff like that. Once I've come up with a design, I'm pretty happy with it. I say, okay, this looks like it meets my requirements. I'm going to hand that off to an architect. I'm going to say, hey, here's the kind of house I've designed. Can you turn this into something that can actually be built? So the architect's going to transform my design into something more tangible. So he's going to ultimately produce a set of blueprints. Those blueprints will define the detailed structural, electrical, plumbing, and so forth specifications of the house to be built. Once I've done that, I'm going to hire a builder, source some materials, and start construction. And then, assuming your contractor doesn't disappear on you, eventually you'll have a completed house. Once the house is done, we'll walk through, we'll do an inspection, and say, okay, does this meet my requirements? Does this meet the specifications as outlined in the blueprint? Does that sound familiar? It should, right? This is the same thing we do when we build a network. We gather requirements, we draft a design, we create blueprints, then we build it or we hand it off to someone else to build. And finally, once we have a finished product, we inspect it, we check it, we make sure, okay, this is what we intended to build, right? Make sure that it meets our specifications. Well, all we're going to do here is swap out some terminology. So instead of blueprints, we're going to call it our source of truth, or source of truth singular. How do we inspect that? Well, we set up monitoring, right? We set up network monitoring to ensure that things are active and connected as expected. That's what monitoring is, right? It's just making sure that the network meets our specifications. Of course, unlike with a house, we only have to do it once, typically, once or twice maybe. Monitoring is a continual process where we're always monitoring the network for changes. So let's revisit the question, what is a source of truth? Well, it can be defined as the functional authority for a domain of data. Functional, using our analogy, our builder used the blueprints to construct the house, right? They were actually being used. They weren't just written down and shoved on a shelf somewhere. They were actually in use. The authority, there was only one set of blueprints, right? If a builder had a question, he'd go back to that set of blueprints and say, okay, this is what it says in the blueprints for this house. He wasn't going to YouTube videos. He wasn't pulling something off of a website somewhere saying, okay, this is what's in the blueprint. So this is what is authoritative for the construction of this particular building. And domain, so the scope of the information. These blueprints are only for our house, and within the blueprints, every specific plan in there had a scope or a domain. So there's a structural blueprint that shows where all the walls are going to go, all the joists and studs and so forth. Then there's an electrical blueprint that shows all the wiring in the house. There's a plumbing blueprint that shows all of the plumbing. Now, you may find information replicated on some of these plans, right? There might be, a note on the structural domain, on the structural plan rather, that says, you have to leave room for conduit or something to be run in this location. But ultimately, it is the electrical plan that dictates where those connections and wiring is going to all go. So let's break this down a little more. We had functional, authoritative, and domain. So functional, it implies that the resource is actually in use. A spreadsheet hidden away on some network share somewhere that only maybe 2 people in a company of 1,000 actually know exists isn't functional, right? Because people who need that data don't know how to get to it, or even if they do know it's there, they might not have authorization to access it. So when we talk about a source of truth, ask yourself these questions. Do people know where it is? Do we know who's responsible for maintaining it? How do I authenticate to it if authentication is in use? How can I get data from it? And most importantly, how can I submit new data to it to ensure that the data contained by that source of truth is always accurate? If you can't answer all of these questions, what you're looking at is not a source of truth. It's very important to recognize that. Second, a source of truth has to be authoritative. That means it is the single authority for the data contained within it. Information can be replicated to multiple systems from that authority, but only one of them can be authoritative. An example of this is, let's say we have 2 domain servers, or two DNS servers rather, and they both define an A record, but they differ. Let's say you have server 1 and server 2. If they both differ, and yet neither of them has been declared as the single authoritative source for that record, do you have a source of truth? You really just have 2 sources of data that aren't necessarily true. One of them may be, both of them might be wrong. Without the ability to defer to one or the other, you don't really know which one is correct. That's why it's very important to have a single authority. Now, that doesn't mean you can't have 1,000 domain name servers scattered around the world, so long as they all agree on which one of those is actually correct. Obviously, we scale out data services quite a bit just to enable us to grow and to answer additional requests and so forth. But it's very important that those are all populated from a single source of authority. Now, does that mean you can only have one source of truth? You have to have this one magical tool that holds everything for your network, and if it's not in there, so it just it doesn't exist? No. The third component, or third attribute that we had in our definition, was the concept of a domain. So every source of truth has to have a well-defined domain or scope for which it serves as the authority. An example in our blueprints was, okay, well, we have the electrical blueprint was one domain, the plumbing blueprint was another domain. So I know which one to look at, and they might cross-reference. They might have, the plumbing blueprint might have a note on there, hey, there's wiring here, make sure we don't run through that. That's fine, so long as it refers to the electrical plan. Now, if it deviates from the electrical plan, right, we would go back to the electrical plan to find out what's actually true, what's actually supposed to be there. Same thing in networking, right? If you have different scopes, for example, you might have an IPAM application that links to some record in a DSIM database or a DNS server or what have you. That's absolutely fine, just so long as there's an understanding that wherever those systems disagree, the actual authoritative source of truth is responsible for maintaining and distributing that correct record. When we talk about scope or domain, size is very arbitrary. You may have a very, very large breadth of domain. You might have an IPAM application, for example, that serves as the authoritative source for your entire global network, and that's perfectly fine. It's ideal, honestly. But the inverse might be as true as well. You have the other extreme where if there's a list of AS numbers and you've only got 4 or 5 AS numbers that you have to keep track of, it might exist as a spreadsheet or a wiki page somewhere. It might not change very frequently. It might only be updated every few years. But even if the scope of that file or spreadsheet is only to say, I hold the AS numbers that are used, and there's 4 of them around the world, and that hasn't changed in 7 years. So be it. That's still a source of truth. So long as there's an understanding that that specific file or spreadsheet is authoritative for that bit of information. It's not ideal, obviously. You'd like to merge and consolidate data where you can, but where you can't, it's still perfectly valid to do that. And finally, there is no one-size-fits-all solution, unfortunately. Every organization, although we end up using the same technology, it's funny, every organization always ultimately differs to some degree, on some points. And you're not going to find a single one-size-fits-all solution or application for this. So typically what people will end up doing is using whatever set of tools and other resources best fits their specific organization's needs. So sources of truth in networking take many forms. If you've not thought about this before, if this is really your first introduction to the concept, hopefully, as I've been talking, you're thinking, oh yeah, this is X is our source of truth for this, Y is our source of truth for something else. Hopefully, you're starting to recognize, yeah, this is the tool I go to. This is the database that I go to answer questions that I have within these specific domains. You might also realize that as you're thinking about this, wait, well, actually, I go to two different tools, and sometimes they don't agree, and I'm never really sure which is correct. And that's kind of what we want to get to the heart of here is recognizing those disagreements and conveying the importance of having a single source of truth for each of these individual domains. On the screen here are some examples of tools that you've likely used. I've often joked in the development of NetBox that the number one IPAM application in the world is Microsoft Excel. The reason for that is it's just so easy to start a spreadsheet when you need to do something, and there's nothing really wrong with that, right? It's perfectly fine to have, if you have a spreadsheet and you have a very small team and everyone has access to it and agrees that it is kept up to date. That's perfectly fine and valid, and it does work for many use cases. That's why it's so popular. But as you grow and as you scale and as you look at more integrations with different things, it makes more sense to move toward relational databases and structured APIs to better facilitate integrations among different tools. On the screen here are just some examples. So you might have different sources of truth on your network might include IPAM and DSIM applications. That's NetBox, Infoblox, BlueCat, PHP, IPM, 6Connect. There's a whole bunch of them out there, all of which offer varying degrees of functionality and scope. They might include just general purpose databases, PostgreSQL. Maybe you've got some custom suite SQL that facilitates specific functions for you. Asset management databases like SnipeID. For other things like configuration templates, you probably just have some Jinja 2 files out there, or maybe you use a different templating language. And those are all just flat files that are kept on a share somewhere or in a Git repository. GitHub obviously is a GitHub and GitLab and so forth. Offer revision control for individual files. And yeah, maybe you just use spreadsheets for something. Maybe you just have spreadsheets stuck around. JSON is again, I think I skipped JSON, but just for general data that maybe doesn't fit anywhere else. So JSON or YAML, maybe you just have a collection of files there. And those are stored in a Git repository. And there's nothing wrong with that, right? That's great. It's not always the most accessible or the most robust means of conveying or storing information, but it's certainly valid. So what about monitoring? I touched on monitoring briefly with my analogy earlier. This is kind of a sticking point that a lot of people, I think, get hung up on because they think about, oh yeah, well, I have a source of truth. It's OpenNMS or it's LibreNMS or whatever other monitoring system is out there. But that's not a source of truth, right? What a monitoring system is showing you represents the operational state of the network. Well, it's not a source of truth, right? If I'm walking through the house that we built and I see that there's a toilet mounted on the ceiling, that's not true. It's true that there's a toilet mounted on the ceiling, but if I go back and look at my actual source of truth, my blueprint, my plumbing blueprint, hopefully doesn't show that there's supposed to be a toilet mounted on the ceiling, right? My monitoring is reporting that. My monitoring in this case being my own eyes, looking up and saying, what just happened? That's monitoring, right? But the source of truth, my blueprint saying, no, the toilet's definitely supposed to go on the floor, so something's wrong. That's why we have monitoring in place. In this case, my toilet needs to be redone. And probably a few other things. Another big difference between the source of truth and monitoring. Sources of truth are defined by humans. That doesn't mean you can't automate things. Obviously, you can automate scripting out things. If you have 1 million IP addresses in use in your NetBox, you're not going to be sitting there typing out each one into your IPAM system, hopefully. Or at least you'll have an entry to it. But there has to be a human logic that goes into this that says, yes, this is what's supposed to happen, right? It's basically, even if the generation of the data is automated or even learned from a network, there has to be a human that gives it a virtual stamp of approval saying, yes, this is what it's supposed to be. Otherwise, if all you're doing is blindly replicating the operational state of a network into a source of truth, IPAM, DSIM application, what have you, all you're doing is taking a snapshot at this moment in time. It's a backup of your network, basically. It doesn't mean it's correct. Even if it's 100% accurate, that doesn't mean that there's an IP address misconfigured somewhere, there are cables swapped somewhere, and so forth, right? A human actually needs to look at this and says, yes, IP 192.168.23.47 is supposed to be assigned to this interface on this device times 1,000. And there's, or a million. And there's ways to facilitate that validation, but that has to be a separate logical process, right? So a source of truth comprises data defined by humans saying, yes, this is correct, whereas monitoring is defined by reality. It's just, this is what's happening right now. Go fix it if something looks wrong. Additionally, sources of truth tend to be static. Now, when we say static, it doesn't mean they can never change. It means that they're only changed under certain conditions, whereas monitoring is going to be the aggregate state of all devices in your network, which obviously is going to be in constant flux. A network of any size is always going to have problems, right? There's links going up and down. There's devices failing, parts failing, interfaces going up and down. Everything is constantly changing on a network, despite our best efforts. That's just kind of what networks are supposed to be, right? They're supposed to be dynamic. They're supposed to adapt to changes. Sources of truth don't. Sources of truth ideally should only ever change in response to new requirements, right? Or the correction of errors. Obviously, if you've identified something's wrong in your source of truth, you need to correct that. But ideally, assuming you're starting with this mythical 100% accurate source of truth, it should only ever change in response to new requirements that have been introduced to the network. Whereas monitoring is always going to respond to both planned and unplanned events. Finally, modeling data. If we have a source of truth, we need a way to store that data. So again, I touched on the earlier slide on a few different ways of doing that. You can have a source of truth can be anything. It can be a spreadsheet, it can be a notepad file somewhere. It's not ideal, but if you've designated that as authoritative for a scope of data and communicated that so that it's functional for users, you have a source of truth. Typically, though, what we'll see, and these are just some examples. This doesn't mean you have to use this or follow this by any means. Just some examples. You might have an IPAM system that exists as a web application with a SQL database, like NetBox or PHPIPAM or any of the other similar applications out there. You might have configuration templates that exist as Jinja 2 files in a Git repository, hopefully. Maybe not in a Git repository, maybe just on a network share somewhere, but ideally in a Git repository for revision control. You might have another Git repo for firewall rules that exists as maybe YAML or JSON data, or even just flat rules that maybe there is no syntax or structure around them. Maybe they're just literally configuration lines that exist in a file, and that's fine too. It all depends on your specific needs. And then maybe you have another spreadsheet out there somewhere to track communication circuits, right? All of those are sources of truth, and they all complement one another. The important thing is just understanding that they should never be allowed to overlap, to conflict with one another. So a little bit of review real quick before we go back through NetBox. A source of truth is functional, meaning it's what people actually use, versus just someone saying, oh yeah, this is definitely our source of truth. And then if you go ask 3 people where it is and they all give you different answers, that's not a source of truth because no one's using it. Second, it's authoritative, right? Single definitive source for a specific scope of information. And again, that ties into domain, right? The well-defined scope of what should and should not be in that source of truth. So now that hopefully we've got a good understanding of sources of truth as they relate to a network, what is NetBox? How does NetBox come into play? So NetBox was developed as an open source IPAM DSIM application originally under the DigitalOcean cloud provider, released in 2016 as an open source application. Today it's got a huge user base and it's under very active development with a new minor release or about 2 to 3 times per year. So it's getting new features pretty constantly added to it. And it seeks to function specifically as a source of truth for network infrastructure. This is different from a lot of, I'll call them legacy. That's probably not the best word. I mean, absolutely no disrespect to anyone else who's ever developed an IPAM DSIM application, because I know firsthand how hard it is. But a lot of applications that maybe predate NetBox or came out in the early 2000s weren't really geared with the mindset of, okay, I'm going to be the source of truth for the network. It's just, hey, I want something better than a spreadsheet to manage my IP addresses. So why NetBox? Well, for one, as I mentioned, it was developed specifically to function for network infrastructure, to model network infrastructure, versus a general purpose data store, right? NetBox comes with built-in data models for tracking data center infrastructure, so sites, racks, devices, cables, all things of that nature, as well as IP addressing. So IP addresses, prefixes, VRFs, VLANs, application services, and much, much more. And it continues to grow, one release after the next. NetBox has a very rich feature set that allows you to integrate with other sources of truth and with other consumers, with monitoring systems, with other user-facing applications. So it's got a REST API. It supports webhooks, which is the ability to basically send outgoing HTTP requests informing other systems of events that have taken place in NetBox. It supports custom scripting, which means you or another user can write a Python script that will actually execute from within the NetBox UI to help facilitate automation or report on certain conditions or whatever you'd like to do. Export templates is another example where you can write basically templatize the output of a list of objects. So NetBox, like many applications, has a built-in default CSV exporter, which is great for getting just kind of a vanilla data set. But maybe you wanted to do something crazy like generate a Nagios configuration file from a list of devices. Well, with export templates, you could do that. You just sit there, you write a Jinja 2 template, maybe play around with it a little bit. Once you get to a format you like, you save it, and you can export, select a number of devices and automatically create a configuration from that. So lots and lots of possibilities there. And if it doesn't do something built in that you want to do, we, in version 2.8, released support for plugins. So now you can actually write custom plugins or Python modules for NetBox, which will do anything from extending the UI to automating background tasks and introducing new data models and so forth. There's lots and lots of stuff you can do with it. And finally, you can do that because it is open source. You can look at the entire source code for NetBox. You've always been able to from day one, and you know exactly what's running. And of course, the corollary that no one really likes to talk about, it's free, right? It's free. You don't have to pay for it. That's great. A little bit about application architecture. So it is a web application. NetBox actually runs on the Django Python framework, which is an extremely robust and very rich framework for developing applications on Python. Beneath that, it runs using Gunicorn or Micro WSGI to interact with an HTTP front end, such as Nginx or Apache. On the database side, it's using PostgreSQL. And we also use Redis, which is, if you're not familiar with it, it's an in-memory key value store. So it's kind of like a database, though not nearly as functional, and everything just kind of resides in memory. And that's used for things like caching and background task queuing. A little bit about the design philosophy. So when I set out to create NetBox, I kind of identified 3 tenets that I wanted to follow, that I wanted to use to inform the development of the product. The first was replicating the real world. The data model within NetBox is very tightly coupled to real world constraints. So for example, when you go to assign an IP address to a device or a virtual machine, you don't assign that to the device or virtual machine directly because that's not what you do in the real world. You assign it to an interface. So if you want to put an IP address on a device, it has to have at least one interface on it. Right? Think about layer 2 and layer 3 networking. You have to have interfaces on the device. You don't just give it an IP. Other things are, IP addresses, when you create them in NetBox, have a mask assigned to them, because in the real world, when you go to assign an IP address to an interface, you don't just put an IP address on it, you put a mask on it as well. That's been true for about 40 years now. The second tenet was functioning as a source of truth specifically for the network. Right? So this has network infrastructure foremost in mind. Other tools out there are much more general purpose. You think about a tool like ServiceNow, which is an extremely powerful tool and well regarded as it should be, but it's not primarily for just networking, right? It's a much more general purpose tool. Whereas NetBox specifically is built and designed with the network engineer in mind, and the data model reflects that. And finally, keeping things simple, right? Because it is an open source application with a limited development ability or resources to pull on. We value, or we try to prioritize high value and easy to implement features over 100% complete solutions. Which honestly, any application you come across is never going to be 100% complete. That's why we make code rewritable. But it's we try to find a good balance between, what is in high demand and provides high value, but also that we can maintain long term, and also avoid cluttering the application with too many things that are too niche or too caveat. So where does NetBox fit into your network? Here we see the consumption of data from one system by another. So in the box at the lower left here, you've got some examples of sources of truth. Maybe you've got NetBox set up for your IPAM and DSIM. You've got some config templates in using Jinja, and it's stored on GitHub. So Ansible, just using this as an example, is going to pull data from all three of these sources, or I guess two sources, NetBox and the Jinja file stored on GitHub, and render render device configurations for the network infrastructure. Once Ansible applies those configurations to the infrastructure, we have network monitoring set up to then inspect the infrastructure and say, okay, is this configured as is indicated by my sources of truth? And that might be NetBox and Jinja. It might be some other external applications as well. You'll have other kinds of monitoring that might go as far as to check the path of a packet through the network and making sure that corresponds to what's been set out. This is just a very basic example of how the interaction should take place, and hopefully give you an idea of where NetBox and other sources of truth, even if you don't use NetBox, how they should kind of interact with the network. Notice that no operational data is ever pushed directly from the infrastructure to sources of truth, right? Again, that all has to be input by, not necessary input, but at least validated to some degree by a human. A human has to have only a human can actually tell you whether or not something should exist, because ultimately it should only exist if it meets the requirements of the business and the intended design. Wrapping up on time here. So getting started, if you like what you've heard, if you want to know more about sources of truth, or you just want to play around with NetBox, NetBox itself is published on GitHub under netbox.community/NetBox. Releases are all published there, and you can see the source code as well. Documentation is published on netbox.readthedocs.io. It's a great place to start. It's probably the best place to start as far as installation, upgrade procedures, and just getting to know more about the data model, even without installing it. And finally, we have a very active community. We have hashtag NetBox on networktocode.slack.com. And we also have an email group set up through Google Groups. That's netboxdiscuss@googlegroups.com. So I'm going to wrap up the recording now and hopefully take a few questions. But I will say thanks again, everyone, for joining me today. I really appreciate it.